Let's look at this interesting math Olympiad problem in geometry. So I have a right angle triangle here with the sides n square and n cube as the hypotenuse. Okay, so we have to find the value of n. All right, so I'm going to start by calling this O as in opposite. I'll call this side A as in adjacent, then this is H as hypotenuse. All right, from Pythagoras theorem, we have that O square plus A square is going to give us H square. Okay, now if we apply that theorem, we are going to have that N square plus N square all square equals N cube all square. All right, so if I simplify this, I'm going to have n square plus n to the fourth power equals n to the sixth power. So I'm going to take n square and n to the fourth power to the right hand side. Okay, so when I do that, I'm going to have n power 6 minus n power 4 minus n power 2 equals 0. And right here, I can factor out n square. So when I do that, I'm going to have n square into n to the fourth power minus n square minus 1 equals to 0. And we have that n square equals to 0, or n to the fourth power minus n square minus 1 equals to 0. Okay, so now from here we have that n equals to 0. But then if we come back to this right angle triangle, n cannot be 0, right? So from here we have that n cannot be 0. So because of that, we are going to reject this particular solution. Then we are going to move on with this particular solution. Okay, so now I have that n to the fourth power minus n square minus 1 equals to 0. Okay, so what I'm going to do is I'll say let's call it p equals to n square. That's because I want to represent this equation as a standard quadratic equation. So that's going to be that I can rewrite n to the power of 4 to be n square all square minus n square minus 1 equals to 0. Okay, so now I can now replace p in place of n square to have p square minus p minus 1. This is not the p square Nigerian musician. The next thing we are going to do here is we are going to solve this quadratic equation. Okay, so I'm going to use quadratic formula where I have my a to be 1 and b is minus 1, c is minus 1. So I'm going to use the Olympiad vibes to solve this. Okay, so from quadratic formula we have minus b, b is what? B is minus 1. Okay, minus minus 1 plus or minus the square root of b square. So I have minus 1 square minus 4a, a is 1 and c is minus 1. Okay, all over 2 times a, 2a is 1. So if I simplify this, I'm going to have that p is equal to 1 plus or minus, this is 1 plus 4. I'm going to have here root 5 all over 2. Okay, now I have here that p is equal to 1 plus root 5 all over 2, or another solution for p can also be 1 minus root 5 all over 2. Now let's look at these two solutions. So if I were to simplify this, I'm going to have a negative number because root 5 is about 2 point something. So 1 minus 2 point something is going to give us negative. And here is the thing. So if we come back to this right angle triangle, the value of n cannot be negative, right? The length of a particular thing cannot be negative. So that means we are also going to reject this particular solution. Okay, we are going to reject this particular solution. Now, that means we are going to proceed with this particular solution. So I have that p is equal to 1 plus root 5 all over 2. Okay, now recall that p was equals to n square. All right, so I can say that n square is equal to 1 plus root 5 all over 2, where n is equals to, so we are just going to take the positive square root of this number, 1 plus root 5 over 2. Okay, you can use your calculator to simplify this. Most times the answer would likely be like this, but then if you were to keep it in the decimal format, the answer is going to be, so I have square root of 1 plus root 5 over 2. and the final answer is 1.272. Okay, so I have here 1.272 approximately. That's 3 decimal places. Okay, so that's the answer. And if you are new to this channel, please consider subscribing and click the bell icon so that you'll be notified once I drop a new video. See you in my next video. Bye.